plus 3y equals 12. Okay. What is that an equation of? Anybody know? What would a graph to be?
An equation.
Well, obviously, but what would that graph to be? Now remember, when we do simple equations like 2x minus 3 equals 7, when we solve this, where would we mark it on a number line? This one would just be on a number line, right? It's on a single line. And x would be, let's add, what should I do first on this one?
Add 3.
Add 3, that's 10, and then divide by what?
2.
2.
It's 5.
X is 5, right? So here we'd have 0, 1, 2, 3, 4, 5. That's the only point that would get marked. That is how you would graph that. It's a point. Okay, that is a point. Okay, every time you solve an equation with just one variable, your answer really represents a what? A point. Equation in one variable. What's the difference between that and the one up here?
There's two variables.
There's two variables. So how will it graph to be? What do you think, Danny?
Wouldn't you just add them?
Can I add the two together?
No.
No, they are not like what?
Terms.
Terms. They have to have the same variables. That's a very good point though, Danny. They have to have the same variables with the same exponents. Exactly the same. That's something I want you to write in your notes, by the way. Take your notes out.
So don't you got a -3?
Well, we will. So, but I haven't said what to solve for yet, but I want to know what it's going to look like before we even try to solve it. But before we do that, let's take out our notes. And I want you to write in your notes, you cannot combine unlike terms, meaning if they're not the same variable to the same exponent, you can't add them or subtract them. If they're not the same variable raised to the same exponent, you cannot add or subtract them. You cannot add or subtract them unlike terms. Okay? If they're not to the same variable, they're not to the same exponent, you cannot subtract them. Okay? All right, now, what should we do with this one right here then? If I want to solve for y. Now, Canyon, say what you were saying.
You gotta do 3 minus 3.
Well, so I want to get the y by itself. So this is the next thing I want you to write in your notes, okay? When you're given a variable to solve for, think about what everything else is doing to the variable before you get rid of it. Think about what everything else is doing to the variable before you get rid of it. Okay? So when you're asked to get a variable by itself, think about what everything else is doing to that variable. What is the 2x doing to the variable y? What is the 2x, look in that equation, doing to the variable y? What do you think, Brian? Okay, is the 2x multiplying to the y? No, the 2x is what to the y? Adding to the y. Everybody got that? Okay, the 2x is adding to the y. What is the 3 doing to the y, Griffin?
Times.
That is multiplying. Now, pedal backwards. What should we get rid of first? Trying to get the y by itself, what should I get rid of first?
2x.
The 2x. That's got to get rid of first. You get rid of addition and subtraction before I get rid of that multiplication. Everybody with me? So Seth, what should I subtract to both sides?
2.
2 what?
X.
X. Keep the variable with it. Do not just ignore the variable. Some of you do that. I've seen you solve equations. Do not do that. Keep the variable with it. Minusing 2x to this side. 3y equals, I'm going to put the x part first and then the number. That's just typical descending order. You always put the variable part first. Okay, now I want to get the y by itself. What should I do to both sides of this equation, Nick?
Divide by 3.
Divide by 3. Now, here is the weird part. Okay, you're Alejandra, right? Gianna, gosh, she's in my other class. Who's this back here? Addie? Addie, what gets divided by 3 on this side?
The negative 2x.
It does. Negative 2 gets divided by 3, plus What else gets divided by 3?
The 12.
Both things get divided by 3. So I'm gonna write this as 12 divided by 3 is what? 4. Now, when we had a single variable, we ended up with a point. Now that we have 2 variables, what do you think we're gonna end up with? So a single variable is a point. What do you think 2 variables will graph to be? What's the extension of a point? Instead of a point, you'll get a what?
This
A
You get a
line.
line. Yeah, you're gonna graph a line. So this is what we call the Cartesian plane. It's gonna have an x-axis, just like this number line, right? Solving for x, this is the x-axis. So there's points along the x-axis. But there's also a what?
Y.
There's also gotta be a y-axis, okay? And now we can make what's called a t-chart. Now I can make the t-chart with this equation. I'll show you this, and then I'll show you a shortcut, which is why we solve for y. So I'm trying to show you why we would get a variable by itself. So Dakota, is what we're gonna do is we're gonna put in some numbers here, x and y. We're gonna put in x's, we're gonna get y's. I want you just to use this equation right here. Put in 0 for x. What will y end up being if I put in 0 for x? Put in 0 right there. That's gonna give you what?
0.
What's 2 times 0? 0, that's gone. Divide both sides by
12. 3.
3, and y will be what? 4. Everybody got it so far? I'm gonna put that point on this xy plane. So x is what?
0.
0. Where's 0 at? Right in the middle, right? And then I'm gonna go up what on the y? 4. Don't mark the point until you've done both the x and the y. So in this case, x was 0, y is 4. Everybody got it? That point is on the line. That's one point on this line. And the reason is I can keep putting in values of x and finding values of y. Okay, let's try this one. Let's try, let's try 3 for x. Okay? What if I put in 3 for x?
Wouldn't it be 12?
3 times 2 would be
6.
6. I'd have to subtract 6. What's 12 minus 6?
6.
6, and then divide by 3.
2.
So if I go over to 3, I should go up to what? 2. So this is the point 3, 2, coming from here. Okay, this is the point 0, 4. Okay, let's go to 6. If this is a line, what do you expect it to do? It should keep going what?
Down.
Down, you would expect it to, right? Let's see what happens. What's 6 times 2?
12.
12, subtract 12.
0.
0. 0 divided by 3 is
0.
0. 4, 5, 6, 0. Okay, let's go in a negative direction. Let's go to negative 3. Where do you think you're gonna be? If I go in a negative direction, I expect it to go what?
Up.
Up. Let's see if that happens. What's negative 3 times 2?
-6.
Add 6 now then to 12. What's 12 plus 6? 18 divided by 3 is 6. Oh, sorry, I forgot to put a 0 down. Okay, so this one's gonna be negative 3 and up 6. 1, 2, 3. 1, 2, 3, 4, 5, 6. Okay. So there's negative 6. Oh, sorry, 3 negative. Negative 3, 6. Sorry, there we go. I connect all those. Yep, what will I get? A line. Could I keep picking numbers?
Yeah.
Can I pick some numbers that might give me a fraction even?
Yeah.
Do I want to? No. What numbers did I pick every time? Multiples of what?
3.
Could I have plugged them into this equation? Yeah, it would have been way easier. Think about this. 0, 4. 3, divide those out. Negative 2 plus 4, 2. 6. 3 divided into 6 twice. 2 times negative 2 is negative 4. Negative 4 plus 4 is 0. Negative 3. Negative times a negative is a
Positive.
positive. 3's divide out. Plus 2 and 4. 2 plus 4 is 6. Is that easier to do?
No.
It's not easier to plug it in here. It was easier to plug it in here.
Yeah.
Really? Okay. There's another way to think of this. This is the y-intercept. That's where it crosses the y-axis. Where does it cross the y-axis at?
Positive 4.
At positive 4. This represents a slope, a rise and a run. I go down how many?
Negative, or 2.
Down 2 and over to the right?
3.
3. Can I keep doing that?
Yes.
Down 2, over to the right, 3. Could I go up 2 and to the left 3? Is negative 2 over 3 equal to 2 over negative 3? Are those equal? Yeah, so I can go up 2, but then I'd have to go what?
Down 3.
Left 3. Up 2, left 3. Could I keep doing that? Yep, will I always land on that line? Is that easier? That's easier, right? So what you do is you actually are changing the form of the equation so that you can graph it, make it easier. Y-intercept, slope. Done. I don't have to plug in numbers. I don't have to make a t-chart. That's why we do it. So that's one of the reasons we solve for a variable. Okay? One of the most famous equations is E equals mc squared. Right? What does that stand for? Energy is equal to what? Mass times what? What? I don't even know what the C stands for. I have no idea, I can't remember. Anyway, it's kind of like force, I think, but I could be wrong. But an E is energy, mc squared. What if I wanted to find the mass of the object? Then I'd have to solve for what? M. It's not that hard because I just got to get the M by itself. How would I get the M by itself? So now the question, remember what's the question that I had you write down in your notes? What should you ask yourself before you try and get a variable by itself? I've got to decide what around the variable I'm trying to get by itself is doing to that variable. What is the C squared doing to the variable M? Tristan, what do you think? What is the C squared doing to the variable M? Is there a plus or minus between it?
No.
So it's not adding or subtracting.
Timing.
Timesing. So how do I get rid of multiplying? Just divide by what? C squared. Will those divide out? Sure. M equals what then? E divided by C squared. Now I can figure out the mass if I know the energy and I don't know what the C stands for, but did you find that
The
out?
speed of light.
Speed of light. All right. Well, there you go. so yeah, that'll if I know the speed of light, which is a constant by the way, so you're gonna know that, and you know how much energy was expanded, then you're gonna be able to find the mass because I solved for M. Let's do another real simple one. The area of a triangle is equal to what? You guys remember the area of a triangle? No.
Length times height.
It's base or length, however you want to think of that, times what? Height divided by what? 2. Okay? Here's what I'm going to tell you. We have a triangle. Its area is 9 centimeters. Okay? And its base is 6 centimeters. Can you tell me the height? Okay. Well, what would I need to solve this equation for? H. So can I get the H by itself? Yes. What do I need to get rid of, Logan? This Logan. To get the H by itself, what do I got to get rid of? And? No. What else do I have to get rid of? B. I got to get rid of both those things. Now, remember what I asked you to do? What question should you ask yourself? What's the 2 doing to the h? And he kind of gave you that. And what's the b doing to the h? Okay, what is the 2 doing to the h? I'm going to ask somebody, so you better be ready to answer this. What is the 2 doing to the h, and what is the b doing to the h? Okay, Briley, what is the 2 doing to the h?
Is it worth dividing?
It's dividing. Good. How am I going to get rid of it then?
Times it.
Multiply. Okay, by 2. Gannon, what's the b doing to the h?
Times it.
How do I get rid of it?
Times it.
Or divide it.
You got to do the opposite, right? So I'm going to times by what? 2 and divide by
B.
b. Those will divide out. Those will divide out. What's left on this side?
H.
But if I times this side by 2 over b, what do I got to times this side by? 2 over b. That's h. Okay, now, given this stuff, can I plug it in? Can I substitute it in and figure it out, what h is? Yeah, it's not that hard. Area is what? What's the area? What did I say it was? 9. 9 times 2 is? 18 divided by 6 is? What was the height of this triangle? 3 centimeters. Can you see how come it would be kind of advantageous to be able to solve for a variable in an equation? Yeah. Let me give you just a fun one. Okay, let's just make something up. Doesn't even matter. Okay, here we go. You can get crazy with it. Okay. Let's say this was the equation. And it said, get the m by itself, or solve for m. That's what it'll say, something like that. Solve for m. Okay? So let's say that's what it's saying. Writer. What is the e doing, the first e doing to the m? It's timesing. What's the ER doing to the M, Jakota? The ER doing to the M.
Oh, adding.
Adding, just adding, right? Okay. What is the Y doing to the M, Griffin? Dividing. So those are the things I'm going to have to get rid of. Okay. Reverse order of operation. What should I get rid of first?
The Y.
The division line, right? I got to get rid of the y. So, Addison, what do I do to both sides of this equation?
Divide by.
It's already dividing by y. I got to what?
Times by Y.
Times by y. Times this side by y. Is that what that parenthesis is saying anyway, is times? Okay, let's distribute this so we can get rid of that parenthesis though, because it's bugging me. So what do I get?
YW minus.
Well, you want to go in alphabetical order. So you want to go NWY, right? As you distribute it, because it's going to get multiplied by it. And then distribute here, what will I get? Again, in alphabetical order. I, N, Y. Okay. So there we go. We got that part. Now, all I have on this side is EM plus ER. Should I get rid of the ER or the E in front of the M next? Think about this. Don't say it out loud. Just think. Should I get rid of the EM the E in front of the M or the ER next? Logan, what do you think? This Logan. What should I get rid of next? Trying to get the M by itself. Trying to solve for M. Minus the ER. So I want to subtract before I divide. So I'm going to subtract the ER. Subtract the ER. Are any of these over here like terms? Are they the same variables with the same exponents? No. So can I combine them? No, just leave them there. Now the only thing left over here is EM. Okay, Sally, what should I get rid of first?
Your.
I want to get the M by itself. What should I get rid of?
Divide it.
I gotta divide it by what? Don't divide by M, that's what I'm trying to get by itself. Divide by what?
E.
E. Everything over here would have to get divided by E. M equals, now I can divide each thing by E so they're separate terms. NWY over E minus INY over E minus ER over E. Oh wait, ER over E, what happens with those E's? Yeah, they'll divide out. E divides E, and I really end up with just minus what? R. That's why you separate them into terms, so you can simplify that last one. Now I got a question. Both of these have a Y in it. Can I subtract them? No, that's a typical mistake. Just because it has one variable in it, it has to have exactly what? The same. If it doesn't, you can't add them or subtract them. But that's a mistake a lot of kids make. They try and subtract there when they can't. Okay? All right, that's all you do. You just get a variable by itself. Give me another typical formula that we've had. Do you know what the area of a circle is?
Oh.
What's the area of a circle?
Pi,
It's cake.
pi,
Pi r squared. It's cake because of the pi is squared. Cake. Logan, that was funny. Logan, are you laughing inside of the mask? What?
I am.
Okay, good. Because pi r squared, if pi were squared, what would it be? It's cake. So yeah, the formula for the area of a circle is cake. So pi r squared. So the area of a circle is pi r squared. Now, here's the tricky one. This is why I wanted to do this, and this is a little bit trickier. I need to get the r by itself. This is a little bit tricky, okay? What do I need to get rid of to get the r by itself? Danny, what should I get rid of to get the r by itself?
Multiply it twice.
So there's a pi that's multiplying to it. What else?
Pi to the.
There's a square that I gotta get rid of. How do I get rid of a square?
Pi.
You actually take a square root, okay? But I first want to get rid of the pi. So Danny, how do I get rid of the pi?
No, you eat it.
Mmm, delicious. How will I eat this one? If I'm multiplying by pi, how do I get rid of it? How do I eat it?
Divide.
Divide by pi. Okay, so now I have the area of some circle divided by pi equals r squared. Now how did I tell you to get rid of the square? This is kind of tricky. You get rid of the square by taking the square root. So I take square root of both sides. That's the square root symbol. The square root of a square just comes out. And it'll leave the square root over here. Do you have a square root key on your calculator? Yeah, you can easy do that. Hey, if you ask her if she'll just spray back there. It's just in the air conditioner.
I was just trying to see if there's any along the.
Oh, there might be, but my guess is most of it's gonna be back by that air conditioner, so. All right, so that's my answer. Is that very hard?
Yeah.
I don't even care. I don't even care what is on the opposite side. I only care that the variable gets by its what?
So,
Self. This is really to make sure that you do the reverse order of operations correctly, that you pedal backwards. Because really, we're not actually going to do much adding and subtracting on the other side of the equation. It's actually easier than what you worded. Okay, take out your workbook, your green workbook, and let's do a few. You can stop the recording now.